Alright, here we're going to be factoring, and we need to think about factor as put into brackets. So get it bound up in brackets. So there's a few things you can do when you're factoring equations or factoring expressions, and what I want you to always think about as the first thing is there anything that both terms or all the terms you have in common? And if we pay attention here, 8 has a 2 inside of it. You could do 4 times 2 and 2. So we see they both have a 2. The next thing I notice is that this first term has a squared and the second term has a. So in fact, they both share at least one a. And again, if I look, I see a b in the first term and a b squared in the second term. So they both share at least a b. And now I can put in a single bracket. And the reason I know this will go into single brackets is, again, because I see that both the terms there share something in common. So I'm going to factor those common things out. And then I'm going to ask myself, what times 2ab will get me back to 8a squared b to the b here. So to get 8, I need to go 2 times 4. And to get a squared, I need another a in there. And to get b, well, I've already got b. 2ab, there's already a b there, so I don't need to worry about it. And for the next term, what times 2ab will get me back to 2ab squared? Well, there's already 2, there's already an a, but there's only one b, so I need one more b. And that's my final answer here. Now to check it, 2ab, 4a plus b, try expanding it out. Go backwards again. And this is just to check your work. Over here we've already got our final answer, but to double check it, 2ab times 4a gets us 8a squared b, and 2ab times b gets us 2ab squared. Same answer that we had, so we did get it correct. But again, this factoring it, putting it into the brackets is our final answer. Taking a look at another expression here. So I'll ask myself the first question again. Is there something everything shares in common? I see a 3, and there's a 3 and a 6. I see an m, and I see another m. So I'm going to pull out a 3m, put down my bracket. 3m times what? Well, I'm missing the p. And 3m times what will get me back to minus 6km? Well, notice that there's that minus sign there, so I need to have a minus 2. 3 times minus 2 will get me minus 6. And I need a k. And there I am done into the single brackets. In this question, I know I'm looking at a quadratic, but based upon what we've just talked about, I'm going to look first, is there something they all share in common? Well, they don't all have a 9 or a 14 or a 2 or a 7 or any number I can pull out. And in fact, they do not all have an m. The 14 does not have an m. So there's nothing they all share in common. So I know that this is going to be a quadratic. So I need to think about that pattern. What times us to the last term and adds to the middle term. So things that time to 14 would be 1 and 14, or 2 and 7. And if I look at that list, which of those will actually combine to give me the 9? And that's right there, the 2 and 7. So I'm going to put brackets with m's in front, and I'm going to have a plus 2 and a plus 7. And I'll double check that. Plus 2 times plus 7 will give me a positive 14, and plus 2 plus 7 will give me a positive 9. So I know I haven't done the right thing. And just to go through a few examples of these, again, thinking about what times is to 12 and adds to negative 7. Well, here I need a 4 and a 3 to get to 12, and they will also get me 7, but you'll notice I need a negative 7, which means I need both of these to be negative. And if I think about that, a negative times a negative will also get me a positive. So m minus 4 and m minus 3. Negative 4 minus 3 will get me the negative 7, and negative 4 times a negative 3 will get me a positive 12. So I've got the answer correct here. So if you notice, there was a positive at the end and a negative in the middle. Both my terms need to be negative. Continuing with our quadratics here. Again, I know it's a quadratic because it's squared. I don't see a common term to all three of those things. So I know I'll need double brackets. And I'm going to think about what times is to 15. So that's 1 and 15, 3 and 5. And out of those, what can I combine together using positives or negatives to get a 2? And you'll notice it's going to be this one. But I need a negative 15 and I need a negative 2. So if I know the last term is a negative, I know at least one of mine brackets needs to be negative and one of them needs to be positive, because a negative times a positive will get me that negative. So if I have a negative in the middle term here, do I need the bigger number or the smaller number to be negative? I actually need the bigger number to be negative and the smaller one to be positive, so that my combination of the two becomes negative, because plus 3 minus 5 will get you negative 2. So whatever sign you see in the middle, if you've got negative on the end, will be for the bigger number. Taking a look at looking at another example, this time we do notice that we've got a negative at the end again. So we should be thinking one of our brackets needs to be negative, one needs to be positive. There'll be an m at the front of both. What times is 28? And we'll add the 3. Well, we could have 2 and 14. We could also have 4 and 7. And 4 and 7 will in fact combine to get me a 3, but only if I have one positive and one negative. Now I need the number that they're combined together to be positive, so I need the bigger one to be positive and the smaller one to be negative. So in this case, it's positive 7 minus 4, again because plus 7 minus 4 will give me a positive 3, and plus 7 times a negative 4 will get me a negative 28. This is a special circumstance here. If I look at these, I do not see a common term to both of them, so I can't get it into a single bracket. And I do notice that it's a square. So what I need to think about is actually these are going to be what we call a difference of squares. One thing you can imagine is I could write that out as m squared plus 0m minus 9. If you think about it that way, what times is to the last term, which is negative 9, and adds to 0? Well, 1 and 9, or 3 and 3. And you'll notice 3 and 3, if one is positive and one's negative, you'll get 0 for the middle term. So that's going to be m minus 3 and m plus 3. So again, I can pay attention to see that 9 is actually 3 squared, and so this is what we call a difference of squares. So it's going to be two brackets, and you're going to have a positive and a negative that cancel each other out, and times to the end term. One more example of that, just to illustrate the point. Here we've got m squared minus 81. So if you want to think about it, what times is to negative 81 but adds to 0? Well, that would be 9 and 9, one positive, one negative. So m plus 9, m minus 9 in brackets, and that would be your final answer.